Welcome, class. In today's lecture, we're going to talk about naming binary ionic compounds, right? So, these are going to be the ionic compounds that we talked about in the last video. Now, you might wonder, why binary? What do we mean by that? Well, binary just means it has two parts, right? A positive ion in this case and a negative ion, right? So, when we say binary ionic compounds, we just mean we're going to name it in two parts, right? Bind the positive and the negative charge. So there are two sort of subtypes of ionic compounds that we're going to name. One of them will be using a metal that only forms a single ion. So for example, we learned that group 1, the alkali metals, always form a positive one. So that would fall under this category. Now the other category is ionic compounds that contain metals that have the ability to form more than one type of ion. So this would be your transition metals or transition elements, right? That don't always form the same charge ion all the time. So we're going to go through these one at a time and learn how to name them. So let's start with compounds where the metal can only form one charge. So I will again hark on this again that we need to start, if we haven't already done so, to learn what these charges are. So these are the metals that we talked about, right? So the important ones that we talked about, right, were group 1, group 2, group 3, right? Especially aluminum, right? Now, you'll notice on this table out of the book, there's a couple more that I will point out that, while I haven't asked you to memorize them as single charge ions, it'll make life easier if you understand, or if you can remember, that these two particular transition metals always form the same charge, right? So we can classify them under this group, right? Zinc is always positive 2, silver is always positive 1. Now, as I said, most of the other metals, the transition metals, right, will form various charges. Usually there's two common charges that these will take on. So for example, iron, we see this a lot, right, can either form a compound that has iron positive 2 or iron positive 3. Copper, right, positive 1, positive 2, etc., right? Lead, positive 2, positive 4. Right? So now, how do we tell these apart? Well, when we get to the naming of them, what we'll see is the key here is this Roman numeral that's listed in red here, right? The Roman numeral identifies the charge. So if I have a compound that contains iron with a positive 2 charge, when I write out the name, I'm going to write iron with that 2 Roman numeral to emphasize that. Now, this book also introduces an older naming system where instead of Roman numerals, we actually use different names for the different ions. This will not be something that I will test you on, right? We will work only with the Roman numeral containing names. That's the more modern, common way that we do this. Okay, so now that we have a little bit of difference between metals that form one ion, metals that form multiple ions, let's start the naming. So, first of all, metals that only form one type of ion. The basic naming system, again, two parts. For binary, we're going to name the positive ion, right? Typically the metal. And we're going to then name the negative ion with the name of the nonmetal, but we're going to alter the name of the nonmetal to end in IDE. So we're going to just use the name of the metal for the positive ion, and then we're going to use the name of the nonmetal, but we're going to change the ending to an IDE. So I'm sure a lot of you have sort of seen some of these with things like sodium chloride, right? And so we've seen that ending, the IDE, and this is where it comes from now. So some of these are very straightforward, and you won't need to really work on them very much. Some of them may be a little bit trickier because you notice we don't always cut off the same number of letters, right? So for the halogens, it's pretty straightforward. We just replace the INE with the IDE. But when we get into things like oxygen, sulfur, nitrogen, right, we have to take all various numbers of letters to get the proper name, right? And a lot of this is for sound, right? So there's a bunch of different ways they could have done oxygen, right? They could have taken off the EN, and it could have been oxygide, but it was decided that the easiest way to do it was just to take off the YGEN and just say oxide. Same thing with nitrogen, right? They took off the OGEN and it's nitride. Sulfur, we'll just take off the UR and it's sulfide. Right? So a couple of them may take a little work. This is most of them. There are a few others that you'll come across, like phosphide, etc. But become familiar with these as we use them. So let's do a little practice. So here's our formula, KCl. So again, as we've learned, right, these are some of the elements that we've had to memorize the names from. So we need to understand that K, right, is potassium. And the Cl, right, is chlorine. And so when we write out the name, we're going to write out the name of the positive ion. The metal is just using the name, so potassium. We're going to take the negative ion, we're going to change the ending to an IDE, and that becomes chloride. So the name of this compound becomes potassium chloride. And yes, before anybody worries about it, spelling does count. So for the most part, we really need to spell these correctly, right? If we don't spell them correctly, right, as we're memorizing these elements and so forth, then they don't make sense. So spelling does count when we're naming these. Okay. So let's look at the second example. So Zn here, right? This is zinc. So our positive ion is going to be zinc. Our negative ion here is nitrogen. And so when I name this, it becomes zinc. And again, we change nitrogen to nitride. And so the name here becomes zinc nitride. Now notice zinc, right? It's one of those couple special transition metals that only forms one charge, so I don't need to specify that zinc is a positive 2 charge, right? I know that it's a positive 2, and that's why the formula is the way it is. Right? Another thing that I'll point out here is, notice when we name ionic compounds, we don't have to specify how many of each of the elements we have anywhere, right? Because based on their charges, we know what their empirical formula is going to be, right? We know the formula for potassium chloride has to be KCl because potassium forms a positive 1 ion and chlorine forms a negative 1 ion, so they only go together 1 to 1. Same thing with zinc, right? Zinc forms a positive 2, nitrogen forms a negative 3, so they go together 3 zinc, 2 nitrogen to balance out the charge, right? So we don't need to write that in the name because the ions dictate how that's going to happen. So what about if we have metals that have more than one ion? So remember I said that we're going to use that Roman numeral, and that is essentially the only difference in the name, right? The name is the name of the cation, so typically the metal, followed by the charge of the metal in Roman numerals in parentheses, followed by, again, the name of the anion, the name of the negative ion with that ID ending. So again, the reason we need these is we have to be able to distinguish between a compound that contains, for example, iron plus 2 and iron plus 3. Right? In other words, we can't name both of them iron sulfide. We have to have some way to distinguish between this compound, FeS, right, which is an iron 2 plus and S2 minus, and Fe2S3, right, where the iron is a positive 3 and the sulfur is a 2 minus, right? Clearly different formulas. And so we can't name them, we can't have the same name here. Right? That's really why we have to specify the charge here. So again, let's look at a couple examples. So copper, so CuBr2, right? So we have copper and we have bromine. Now, while we know copper is one of these that can take on multiple charges, now we don't have to memorize those charges. You know, we might become familiar with them as we practice them, but we should be able to look at the negative ion and tell us what the positive ion is here. So we know that Br, right, is a -1. Right? It's a halogen, always a -1. So the fact that this formula, we have 2 of them, tells me that the one copper here has to be a positive 2 to balance out the -1 ion charges, right? So the only way that this formula works is if copper is +2, because each bromine has to be -1. So when I go to write out the name, I know that it's copper 2, and bromide. So let's look at the next one. So again, lead. Well, can have multiple charges. So how do we know what the charge is here? Again, we look at the chlorine here. Well, we know chlorine is a -1, right? Because it's, again, a halogen. So we have 4 of them paired with only 1 lead. Well, that means the lead has to be +4, right? It's the only way that this formula works. So when I go to write it out, I'm going to write out lead and the Roman numeral 4 chloride. So lead 4 chloride. So same basic naming system, but when we're dealing with one of those transition metals besides zinc or silver, we need to specify the charge by using the Roman numeral. Now, one last sort of variable here, and this is, what if we have an ionic compound that contains one of those polyatomic ions? So the key here is we use the name of the polyatomic ion whenever it occurs in a compound, right? So we don't change the name. So normally, right, and we've learned that we would change the negative ion here, since most of them are going to be negative ions, we would change that to an IDE, but we don't. We simply use the name of the polyatomic ion. So if I have the formula NaNO3, we're going to have the positive ion, which is sodium, Na+, and we will learn that the NO3 minus polyatomic ion, right, that's the nitrate ion, NO3 minus 1. So when I go to write the name, I'm going to use the name of the positive ion, sodium, and I'm going to use the name of the polyatomic ion, nitrate, and it's simply sodium nitrate. The Roman numeral idea is the same. If we have a metal that always has the same charge, we don't need it, like sodium. If we were to have a metal that could have multiple charges, again, we would have to specify that with the Roman numeral. So let's close out with a little bit of practice. So first thing is to identify what we got going on. So first of all, we remember that potassium is a positive 1 ion, and the SO4, right? This is the sulfate sulfate ion, right? And it's SO4 2 minus. So we have potassium, right? Potassium is always positive one, so we don't need the Roman numeral. And the SO4 2 minus, right? That is the sulfate ion. So this compound becomes potassium sulfate. But look at this one. We have an Fe, an iron, and we have a Cn ion. We have two of them. So again, iron is a metal that can form multiple charges. So how do we know what the charge is? Well, we base it on what the negative ion is. So if we remember that this is the cyanide ion, right? Cn minus 1. We have two of them in our formula. So that means the iron here must be iron positive 2, right? So when I start to name this out, it becomes iron 2 cyanide. So same process. The only difference is when we're replacing the polyatomic ion, we're just using that name. So here's an example with NH4Cl, where the polyatomic ion, right, is replacing the metal, right? This ammonium ion, which can replace the metal, right? It is NH4 positive 1, as we remember. And of course Cl is Cl minus 1. So we got positive 1 here, negative 1 here. And so the name, again, we're just going to use the name for the positive ion. So ammonium. And for the negative ion, again, because it's an element, we're going to change the name to an IDE, and it becomes ammonium chloride, becomes the name of this compound. Now, one of the questions we often get with polyatomic ions is, if I'm looking at a formula, how do I know that there's a polyatomic ion there? Well, one of the easy ways to remember is that, remember, these are binary compounds that we're looking. So if there is no polyatomic ion, then there will only be two elements. So like sodium and chlorine, or potassium and bromine, right? There's only going to be two different elements in a binary compound, right? So in the same way, if I have a polyatomic ion, there's still only two parts, but if I see a compound where there's more than two different atoms, like K, S, and O, well, that's a good hint that there's a polyatomic ion in this ionic compound, right? Because I can't name it as a normal binary because there's three elements. So that's your hint that we have one of our polyatomic ions present in our compound. Okay, so next time we're going to shift our attention to learning how to name molecular compounds.